Thank you very much for watching our presentation regarding power-based side channel attack and countermeasure design for cryptographic algorithm in energy system. My name is Miaoqing Huang. I'm associate professor at the CSC department. Our team includes myself and Dr. Chris Funder from the E department. In 2016, NIST started the PQC standardization process to select a few algorithms to replace RSA, which becomes vulnerable facing a quantum computer. These new algorithms need to be evaluated against side channel attacks before they can be deployed. We have two objectives in this project. The first one is to perform power-based side channel attacks on 4 PQC algorithms implemented on 2 edge devices, including the TI, DSP, and one latest FPGA. The second one is to design a side channel attack countermeasures to prevent leakage from those implementations. At Arkansas, we have developed a multi-platform and multi-target infrastructure to perform power-based side channel attacks. We have a Tektronix oscilloscope and a chip whisper light to collect power traces. We also have 3 implementation platforms, including one FPGA for hardware implementation and 2 microcontroller boards for software implementations. Once we have the power traces, we use TVLA to detect leakage. These 2 diagrams show the results of the Kyber algorithm running on the FPGA and the microcontroller respectively. We have 3 research thrust in this project. In thrust 1, we will implement 4 PQC algorithms on the USB board, which contain the TI, DSP, and the latest FPGA. Once we have the implementations, we will perform side channel attacks. In thrust 2, we will apply different countermeasure mechanisms, including masking, hiding, and shuffling to make PQC algorithm SCA-proof. In thrust 3, we will expand our capability by collecting electromagnetic radiation traces for side channel attacks. We have purchased a set of Langer near-field probes for this purpose. Next, Chris is going to give an overview of the UCB architecture.
Hello, my name is Chris Farnell. I'm going to be giving a very brief overview of the Unified Controller Board architecture, otherwise known as the UCB. So in this upper left quadrant, you can see the UCB with some peripheral cards installed that we've built up. The main reason we built the UCB up was so we could leverage some of the design and code reuse for our various projects related to electric vehicles and grid-connected devices. This is a block diagram of the UCB architecture. And the DSP that we're planning on using is the Texas Instruments F28379D dual-core Delfino. And here you can see the block diagram of all the associated peripherals with these digital signal processors. For the FPGA, we were previously using the MachXO2, but are upgrading to the MachXO3D. It has additional RAM, and it also has more lookup tables and integrated cybersecurity features such as true random number generator, AES encryption and decryption, public-private key pair generation, and we're hoping to use these resources in order to integrate the cryptographic algorithms into this unified controller board such that we can make all of our future projects related to controls and electric vehicles, grid devices, and other related subsystems more secure. Thank you for your time.
Thank you. Now we are open for questions.